it's not going to like this. Let's edit this. Oh, it's not going to like this. Let's edit this. Okay, let's hold on. That was a big audio. Okay, we're gonna play some Shenzhen. It's gonna be a game by Zachtronics. I pre-ordered it, so I got this cool binder. It's got a. I actually know what this looks like. This is a binder full of documentation for this new chip that I'm going to be programming that is entirely fictional, not real. There's some cool things that I like, feelies from the old days, right, from the old video games. Got like a business card with somebody's name on it, like from this actual company. All the emails are printed out, and most mysteriously, there is a envelope that says "Do not open," and it is sealed with a confidential stamp, so they'll know if I tampered with it. Let's see. We've got this language reference card, so if you know how to program microcontrollers, if you know some like basic assembly language, that it's probably close. Simple instruction kind of thing. I haven't done this kind of stuff since the last Electronics game I played, which was TIS 100, and which was just this concept. And before that, school, college when I did this for a grade. This is probably going to be fun, but let's find out. Let's see. I think the basic story is that I have moved to Shenzhen for work. It's in China, like across the way from Hong Kong. It's like on the mainland side of Hong Kong. And I also believe that it is the year 2026, 2020, sometime in the future. Some emails from my new coworkers. Important, read the manual. I think, that's good. And then security camera, fake. So I think this is the first mission. So let's take a look. Product is an imitation mock security camera. There's two blinking lights. First blinking light, regular pattern. The second light is an internet light. Resemble data upload. Okay. As you will notice, the design is partially complete already. Quit. A physics engineer quit before finishing the assignment. Note the timing diagrams in the verification tab. When you simulate, your output should match those expected values as indicated. Let it run for 4 full test runs, okay? I'm absolutely certain you'll do better than that last program. Let's find out. Alright, so I guess this whole thing is like a tablet interface. I'm working from a tablet, which is something I swore I'd never do. Okay, create a working design. Okay, so this is when the leaderboard is shut down there. Okay. Oh, I love this. Hey, it's 2026. I wonder if this little mascot has a name. Caddy? Caddy? That's a terrible name. Chippy? We'll work on it. New design 1. Let's take a look. Open design. Copy, rename, delete. Okay, open design. Let's take a look. Active network are simple outputs connected to LED. Controller. So, full truth, I might not get anywhere. I've only looked at the manual very, very briefly. So it's entirely possible nothing's going to happen. Okay. Control the active and network outputs. Fix repeating signals as indicated. It should look like this. That's the actual. Yeah, that's neat. Okay. Simple output goes on and off every however many cycles those are. Let's take a look. What happens if I just hit go? Hit go. Oh, just one back. Go the whole way. Okay, it looks like that's actually happening. So, do it again. Oh, I see. So, okay, so this is the... Why is this so hard? You can comment in there. That's kind of neat. Okay, so what's happening here is we've got move 0 into P0 into... Oh, so this is an output. Okay, so I'm moving a 0 signal into P output and then sleeping 6. Then moving a value of 100. Okay, so what I remember reading... I say okay a lot. The simple outputs, which both of these are, can take a range of numbers from 0 to 100, a range of values from 0 to 100, all integers. And each of these pins is an output on this chip. So if I take this other chip, I can write in code which will say, hey, I want to move a value of 0 to this output, or I want to move a value of 100 to this output. So I'm going to, how do I draw wires? Ooh, that's neat. I like that. I want to draw a cooler looking wire. Alright, neat. I want to draw, oh, and you can branch them. Ah, that's pointless and silly. I don't know if the pins mean anything. I don't know if the pins matter at all. I'm going to do something weird, like move... I'm going to move whatever's in ACC. So ACC, I assume, is my accumulator into P0. Okay? And I'm going to do something crazy, like add 1 to accumulator. Then too many operands? No? Oh, add 1 just adds to the accumulator no matter what. Or whatever value I add goes to the accumulator. The accumulator is... It's like a buff. It's a register that's holding a value. So I'm adding 1 to that value every frame. I don't know what happens if once it hits 100. Sleep. Don't sleep. Just keep doing that. Just keep doing that over and over again. Let's see what that looks like. I expect this to look like a ramp. It's just going to move. Network output is just going to look like a ramp. So let's find out. Part not sleeping. Oh, and it's just using tons and tons of power. That's great. Alright, so how about sleep 1? Yeah, so it's just slowly accumulating. It never really got to 100. That's interesting. Got to 26. Control click to toggle breakpoint. Oh, I can put in breakpoints in this? That's cool. Can I scroll through this output? No? Okay. Okay. Cool. The profile that shows the power usage. 45. This got to 45, so that's... Alright, let's reset. 100 and 0. I don't know. Okay. Oh, this is a regular pattern, so... Do I have any indication of what this pattern should really be? I can show the wires underneath. You can connect wires underneath! Woo! Let's not do that. Okay, right-click deletes a wire. Okay. So it looks like... Okay, so I know that's a 6, so this is probably 4, based on how it looks. So I'm going to do something very similar to what that does. So I'm going to say sleep, move 0 into P0, right? So that will put a 0 value out into that pin, to network pin. I'm going to sleep 4, and I'm going to say move 100 into P0, similar to what the top is doing, because it's just flipping a switch off. And then after that, it needs to sleep 2 to get to that first 6, yeah? Then move 0 into P0, move 0, please. Okay, and then sleep 1, that looks like a unit of 1, move 100 to P0. That's it. That's resetting the clock here, yeah? Maybe? And that should repeat forever and ever, maybe? Move 100 into P0? No, I guess it'll have to sleep 1 again, so that it goes that far. And then, this is zoom. I don't know what that means. Oh, that's probably for the speed adjustment. I gotcha. Sleep 1, and then start over. 0, sleep 4. Start so on. Okay, right? Maybe? This might work? I think this is going to work. I'm very confident. Yeah? That looks good. That looks good. 3, 4. It's going to do it. Cool. Go. So it says it's a random. It's definitely not random. It's not random at all. Hey, his name is Chip. Nice. I like Chip. Oh, it's power use per instruction, maybe? Instruction cost? Cool. 6 yen. Why are we using yen in China? It is also for RMBs. Okay, cool. So power usage is actually a metric to use. So there is probably a way to make this use less power. I don't know what that might be. I don't know actually how power is calculated here. Let's go back. Let's take a look at the new thing. Nice. Objective complete. Thanks for your prompt work on blinking lights. Looks okay. Thanks, Ji. Zhang Ji. Shenzhen days. I can't read Chinese, so I have no idea how their names are actually pronounced. So, yay. Hi everyone. New sign-ups. I'm your host, Tilly Liu. I run this fun little mailing list for expats in Shenzhen. I'm here to demystify some aspects of life and culture here, along with a side helping of color commentary. Sometimes just the color commentary. Cool. Today's topic is, why the heck are we in Shenzhen? No, really. It's an existential question. We all have some jobs, some businessy thing. But let's talk about larger factors at play. We're here because Shenzhen has been one of the fastest growing cities in the world for the past few decades, ever since it was declared a special economic zone back in 1980. We're here because it, and really the entire Pearl River Delta region, is a sprawling megacity wholly dedicated to trade, manufacturing, and services. A giant economic machine. We're here because what's possible in Shenzhen really isn't possible in many other places in the world, certainly not at the same scale and cost. So where's all this capability headed? In the future, which we are in. This is the future. We're going to just make more stuff, more products and things until the world is buried in crap. It's a good trend. Where's incredible growth for, anyway? There's some ideas, but that's a topic for another day. She seems nice. Silly. Replacement factory module. So I'll look at both of these before I pick one. Please enjoy a game. Our factory floor has examples of older equipment that require control signals to be amplified. There's a device to adjust signals for this type of machine, but recently was broken. Smashed? What is going on here? No need to worry. That always means I should worry. Carl's the voice of reason here, it sounds like. My daughter's learning programming. She created a simple card game. I'd like to try to give some feedback. Put a link on everyone's desktop. Oh, I got my desktop. They both farmer managed to design quite the challenging patience game. Undo. She says she doesn't think it needs undo because it's actually quite easy once you develop some skill. Win a game of Solitaire. Let's take a look at that. Let's go look on the desktop. Look at that. Solitaire. Hello. This is very advanced for a child. Hey, look, they're using mahjong tiles. That's neat. Is this Solitaire? Is this like I don't know. I think I have to read, I guess. I've probably already made mistakes. Oh no. What does that mean? I don't know what that meant. What just happened? I'm clicking randomly. Man, is this what things are like? Move the 4 and a 5, no. 5 and a 4, no. 5 and 6, no. 8 and a 9, no. I just keep trying the same things. Maybe it'll be different this time. No. No. Yeah. Okay, let's look. To win, stack these 3 suits from 1 to 9 in the top right button. Okay, that's Solitaire-ish. Cards can be stacked and moved to the center tile of the table, but only if there are alternating suits in decreasing values. In the center of the table. Okay, that's a lot like Solitaire also, but is that only off that one column? Maybe? The pieces on the top are able to store one card of any type. Okay. When all 4 dragons of a single type are exposed, they can be permanently moved to an open free cell, pushing the corresponding button. Permanently moved to an open free cell. Okay, I don't really know. Should be able to put this 8 on something, though. Okay, I've learned something. There is one more green dragon somewhere. Oh, it's there. Shoot. Let's start a new game. Oh no, I can do this. Do that. Do 7 here. That's nice. 4 goes into 5. I see, and those slots are very nice for just holding things. Which is where I should have put these 9s so that I could use those slots. Alright, let's start a new game. Alright, let's do it again. Okay. Let's put 4s on the 5s. Okay, what else have I learned? Dragon there, the dragon here. It might be a good idea to move one of those dragons just so that I can unlock some things. I can do that there, I can do this 3 and this 2, or this 2. Move that 2, 5, 4, 6. Oh no, that 2 would still be there. I guess I should trust my instincts. That doesn't mean anything. 9, 8. That? Or this is the center, is that what they meant? Okay. Something to note, I just picked up an engineering game, and now I'm playing Solitaire in it. Let's see. Yeah, let's do that. Okay. You know, that's what killed me last time. Killed me. Move that 2 down. No, I can't move it there. It's not allowed. But I can move it here, so I can move it here, so I can move this here. That's not bad. Oh, okay. Yeah, that's the issue. So if I move a dragon up here, it's like permanent. There's nothing I can do about it. But if I move any number there, I can move them back down when there's space. Okay. Okay. I can see that. That makes sense. It's a strategy. Move that there, so I can move this here. Do that there. I don't know if this game's actually always beatable, right? I have no idea. I don't know if anyone's ever proven that. Solitaire is... Well, this game specifically, I have no idea, but Solitaire in general, I don't know if that's always beatable. I guess it's not. We got 6 there, then that 4, the 2 would be permanently locked up there, I don't want that. 5, 4, let's move out, that's 6. Oh, my 1's at, back here. This 6 is back there, 2, 9, I want that 8 out. That's right there. Oh, 7. Oh no, these are 9, 7, so it's fine. These are the 9s. Dragon 7's back there. 2, 3, 4, 1. I move that 2 out there. I can move that 3 here. 4 stuff. I move the 4 out to get the 1 to get 2, 3. 4? 3? 3's here. Oh, but I can move that. No, but the 2's here. Okay. Number emblem. 6 useful anywhere. 1. Move that there. Get the 6 out. Get the 1 up. Okay, yeah, let's do it. Good job. Can I move this down? I can. Excuse me, can I move this on? No, that's fine. That's fine. It may have been more useful to do it the other way, but for now, it's okay. Learn. We'll put that 5 up there. Let's do this. 2, 3, 4 down. The 1 goes up. Okay. It's nice. There's another white dragon. Move these all there. don't know if I'm gonna lock that up yet. Yeah, let's see it. 1 out. Yes, please. Thank you. 2 red dragons up, 1 white dragon up. I need to get rid of some things. Second of green 7, second of black 6. Second on. The rose just goes there, huh? It's just one of a kind. Green 7. Have all the whites? Nope, that one's stuck there. 6 go. That might be a mistake. Oh, I probably made a mistake. I need to get rid of these. Okay. Okay. Terrible at this game. Need to get rid of that. Do that. Or I can do that. Okay. 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 I think I'm permanently stuck. Good game. Once again, this is a game about engineering that I'm playing Solitaire on. A dragon there. This one might not be beatable at all. This looks terrible. It's an awful situation to find. It's a horrible night for a curse. No, I don't like it. That. I have a dragons. More dragons. Get some 6 over there would be helpful, but nope. 7, that is a 6, 3. The 1 there, the 1 there. Oh, you beat this one, man. It's too hard. Nice. 2. Nope. I'm just gonna start a new one. Oh no, all the ones are over there. Oh no! Doom. Level 1 out. Okay. Put it back there for now. 3 dragons there. Where's the 4th there? On top of 6, 5, 4? Okay. I think I can get rid of these. If I do this. Do that. Hit the button. Cool. Oh, but it locks the slot too. No, I didn't know that. Maybe it doesn't matter. Maybe that's okay. One there. Put this back for now. 8, 7. 2 white dragons out there. 6. Okay, that's nice. These 3 can't go anything in particular right now. This 4 can. If I do this. Put that on there. If not, okay. Get rid of this 3? No, where's the 2? 2's way down there, so that's not gonna work. How about another 4? That 4? How can I get rid of this 7? Let's try to get rid of these white dragons. Let's see. Oh, I can put this 3 away. I can put this 3 here. That helps. 2 white dragons. Now there's 2. I put the 8 up. 2 goes away. White dragon, white dragon. Nice. Okay. That's nice. Let's see. Can't go on that. These can go on there. No, they can't. You know that though. Over here. This can go there, this can go there. There's 5 go there. This can go there. That matters too much. This can go on that. this out. That can go like 2 bits left. Just get some slots. Okay, that's fine. 7, 6. 2 queens. That's queen there. Move that up there. Move this out there. Greens. Goodbye. Fill it. Yes. That's what it's all about. The card's pouring down. Cool. Tell me I won. Is that it? Did I win this mission? I did! I can't read Chinese. How something something then something 不下 something. 名人儿 your daughter 天才 you know what that means. An old something. Your daughter. 她的 something something has something 太好了 very good. How 工作 very very good work. Okay. Guess I should do the real work now. Let's see. Okay, new design. Looking at... Okay. Control signal amplifier. Control in is simple input connected to factory equipment. Control out is a simple output connected to other factory equipment. Signal from control in should be multiplied by 2 and copied to control out. That's easy. We love multiplying by 2. Let's take a look. Alright. Control in. Oh, this is an amplifier. Okay. Just take the control in, multiply by 2. So, this, I'm going to take control in. Pin type mismatch, so it doesn't work that way. I don't want these X. I should probably do. What are X1? I'm going to look this up. Well, they're registers, but that's the same as anything else. X1, X0. Let's see what this thing says. I'm reading in my manual. Nope, nope, nope. I don't know what those are. Express? We're gonna make part data sheets. Ooh, okay. Oh yeah, those are X bus. So those are different types. The X bus lets you send like an integer, like a single number, over to the other one. Okay, let's see. Just realized I had somebody on Twitch chat, so I should put that up so that I can read them sometimes. Okay, let's see. Multiply by 2. So, I mean, the easiest way here, and by easiest I mean probably my first pass that's going to be wrong in some way. I'm just going to move P0 to accumulator. Does that hold? Does this data hold? Oh, I can move twice. So because I can move faster than add. Do I add? Can I add? I can add P0. Okay, let's do that. Does that work? Is this gonna work? I have no idea. That'll work. So what I'm doing here is I'm taking the data that comes in on the control end, storing it in the accumulator, then adding the data that's still in the P0 slot into the accumulator. This should add twice. That should be double. Then I can sleep. Sleep one. I guess I want to move that out. So move accumulator. Is there another thing that does that? SLX. I don't know what SLX is. It takes a pin registry though as a. Okay, this is fine. Move that to P1. Let's see what happens. I don't know what's gonna happen here. Okay, move. So I get a 25. I add 25. Okay, that works. Move that out. Sleep. Do it again. 0, 0, sleep. Yeah, go for it. Look at me, mighty engineer. I wonder what the learning ramp on this is going to be. I guess somebody always beats it in some weird ways. These tutorial levels, even though they're designed to be super simple, somebody always like breaks them. Yeah. Yeah, people should stop smashing things. Smashing is bad. Please enjoy a game. I did it. Did that already. I'm going to read this at some point in Chinese or look up what that actually says because I would like to learn Chinese. An update supply agreement to give us access to a new part. Much like the 4000, your data sheet can be found with other papers. I'm going to look. Look up the data sheet. Part data sheet. MC 6000. Okay. Looks like it's got more pins. Plus we've got a DAT register in addition to an accumulator. Okay, also the bridge part reorder is in. The bridge enables jumping over traces, may be useful for smaller boards. Okay, cool. This time we have many. 10 million. A tiny dirty. Take an orbital selfie. Oh, I like the future. 9,999. Dear Adventurer. Space Adventures Moscow. Alright. Experience the stars in the Earth as you've never seen them before. Enjoy the surprise and delight of true weightlessness. Of course, take pictures of yourself and nobody will soon forget. Know that there has never been a better time to take a trip to low Earth orbit. Demand is skyrocketing. God. Prices are cheaper than ever. Now's the time to get in on this trend, which has been popularized by international superstar Cool Dad and many others. Cool Dad. Tickets are going fast. Pulse generator. In order to test some of our new manufacturing equipment, we need a pulse generator with certain requirements, specifications. However, instead of buying one at market price, we thought we could simply create our own. This project, we will make use of conditional execution. Let's continue your study of the language ethic. Nope, I did not mean to pull out this envelope that is taunting you until I cannot open it. I meant to pull out my instruction sheet to see what conditional execution I have. Maybe there'll be something in there. Let's go. Let's take a look. Open design. Button. Simple input connected to a button. Makes sense. Pulse. Simple output connected to an electronic device. Alright. Hey, and bridges. When the button is pushed, generate pulses as indicated in the verification tab until the button is released. Okay. It sounds like it will require a button. Okay. So you just want me to pulse every one frame. Okay. Do I need the new chip? I might not even need the new chip. I need a big chip. Ooh, that's kind of cool. Costs nothing too. That's kind of cool. I guess since the wires cost nothing. Look at that. That's not gonna work. That's a bad idea. Okay. Conditional execution. Let's find out. Look at the language reference. Program structure, blah blah blah. PEQ. Conditional execution. All instructions in the MC4X programming language are capable of conditional execution. Prefixing an instruction with a plus or minus symbol will cause that instruction to be enabled or disabled by test instructions. Ah, that's clever. Better than branching, because branching is a pain in the ass. When an instruction is disabled by a test instruction, it will be skipped and not consume power. Instructions with no prefix are never disabled and always execute normally. All conditional instructions start in a disabled state. A test instruction must be executed to enable conditional instructions. Cool. Let's take a look. There's an application note 650 touch activated light controller as well. 650, 650 touch activated. Okay. So, the language allows for, let's just do it a simple one first and see what happens. The pulse is just straight up, so I don't think I need any, I don't think I will need, the nice big new chip. So let's do this. P0 to P1, okay? Starting from basics, let's just do, move P0. This might need, okay, this requires some thought. I need to think. Well, okay, I feel cheap, so let's use, cheap in the sense of I don't want to think. So let's pull in a nice chip. I'm gonna do, say, use the DAT register to hold my state. So, assuming we start from 0 state, which I guess I don't know if that's safe, but it seems safe right now. Test that P0, test equality, P0 and DAT. Okay, so now, if those two things are equal, actually do nothing. I want you to do nothing if those two things are equal. So, I want you to do the opposite. Do this. If they're equal, if equality is true, it disables that. Is that correct? Oh, okay. So, okay. Gotcha. So I'm reading this on a different. I'm reading this in the sample that they provided. So let's look at this. I'm just going to write what they do first. So that's cheating. So this detects a rising edge. So TQ, accumulator, and 0. So it's using the accumulator as that DAT, which is what I'm planning to do. I guess since I don't have to do any actual math, that should be perfectly valid. So okay. If the accumulator does equal 0, I'm going to run another test that says, does the input equal 100? So now it's saying, hey, I check my storage state. If it's true, activate this next plus line. And I guess this only, well, I guess this only applies to the previous line. I don't know what happened. My brain is thinking of ways to do things that maybe break some things. Break this format plus minus format. I see what's been thought through. Most of these things usually are. Okay, so now I'm testing equality if it's a rising edge. So there's a new edge, and now the new thing is high. So now what I want to do is I want to move. I want to oscillate. Okay, so how do I do that? If I do, so on the rising edge, I do want to move 100 into P1, and if I want to sleep one, and then I want to move 0 into P1. Okay, I mean, that's all fine and dandy, but now I need to shut down. Okay, I'm gonna run out of space on this chip, so I gotta think further. Let's keep going. Let's keep going. Don't edit and create at the same time, right? I kind of want that to be like a subroutine. Is that possible? Is that a thing I can do? I guess it'd be a separate chip that you activate. Alright, I mean this won't work, so this will do. Does it? No? Huh. Alright. I want to see something. Okay. Oop, spit all over things. Oops. I may have accidentally come up with a decent solution. And it is incorrect, probably. It's a good thing that default starts at 0. Okay, so here's what accidentally happened. Just play through the whole thing. I gotta fix this because this is wrong. This is doing a lot more work than it needs to. So, let's go back. No, continue editing. Let's fix this. Okay, I don't have to do this first part at all because I'm not throwing anything in the accumulator ever. So I don't need that equality test. I do need that. Let's see if this still works. Yeah? Okay, so now all that's happening is I'm detecting if it's 100. If it's 100, oscillate. If it's not 100, just continue on, which is the same as pump 0, I suppose. Power usage is low. Cool. Production cost is still low. I'll make it lower still. What if well, let's just rearrange. Move P0. No. P1. It's the same number of cycles, right? And I don't know if that logic holds. I guess it does. I save one line, maybe? That's still like 130. Power usage is even higher somehow. How? Oh, do these lines take more power? So by testing, do they? Oh yeah, because now I have to move. Although I don't know how much power things use, so I have no idea. The high power line. I'm going to do all this. Maybe. Yeah, now it's 128. So there's some way to make this even lower, I think, but I have no idea. I have no idea why. What was the difference last time? I guess the difference last time was I was running 2 commands for sure every time. Or 3, I guess, including the sleep. Now it's only running 2, including the sleep. Okay, okay. That's fine. I accept. I'll run them all and get through it. Okay. Alright. Suitable for our purpose. He's not the most emotive guy. Lit up signs from Joe. Major esports person, anyway. Solid Steel Gamer. Their teams contacted us to make a light up sign that actually animate for her fans. That's fun. When you keep the cost down, they're going to want tons of these handout matches. Looks simple, just a few states. Okay. What about you? Rubbish audio thing. Contract comes in to build a piece of audio kit. Sounds fun. I like audio. Client promises that their little box will deliver crisp highs and booming lows all in perfect balance. Okay. The copy of that. Just look in the pile of papers marked supplemental data since that seemed most appropriate. Okay. Take a look. He also mentioned that we still have to do this as sad as it is. Work's work, you know. Okay. Let's take a look at this. Supplemental data. Copies out of the bio. Yeah, feelers, paper. I like paper. Double sound of breakthrough pace. Okay, harmonic maximization. Relatively breaking out. Configuration looks like some pretty standard, like copy from the 1980s. Maximize. Railroads and back won't like that we're showing it to you, but go on. Have a peek at the proprietary harmonic maximization formula. Audio out equals audio in minus 50 times 4 plus 50. What? What? That doesn't mean anything. Audio in minus 50 times 4 plus 50. Well. Let's not do math yet. Let's look at the light up sign. Take a look at this first. Tips. Drag with the middle mouse button. I don't have a middle mouse button. Look at different parts of your design. Oh. Alt click. Ah. Go away, wires. Okay. Animated esports sign. Click 0 and click 1 at simple outputs corresponding to display segments corresponding to a clicking animation. Okay. Drink 0, drink 1, drink 2 are simple outputs connected to display segments corresponding to a drinking animation. Okay. Control a display segment with fixed repeated signals as indicated in the verification tab. Alright. So we're just oscillating on it. Oh boy. These are all outputs. Oh, that's neat. Okay. Okay. So there's no input, it's just output. Right? So what are these? What do these look like? I only got one output there. Can I kind of base them off each other? Can I chain them with each other? I guess I could. Let's do one in an invert. That's we're gonna cost three RMBs to invert. That seem reasonable? 6 RMBs to do one signal. I guess 2 signals. Okay, let's try it. 100. I know, that's good. Move. Sleep 1. Move 0. P1. Repeat. This is poorly thought out. Come here. Said, come here. Okay. That works for there. Okay. Let's take this guy. I guess that's the closest it gets. Oh, I can do that. Nice. Do that. Move you here. Space it. Oop. Okay. 2-0. Move. Oh, how do I invert? Shoot. That's not actually easy. That's annoying. That actually requires code. I don't want to do code. I just want to invert. There's something. Pictures of no sleep. It's fine. Generator, touch protection. Oh, that's it. That's the only. Okay, look at the language there. Table condition instruction. Yeah, language doesn't give me that. Oh, not. There it is. Now, what do you got for me? Sleep. Add. Subtract. Multiply the value of the first. Okay. Not. Cool. Not. If the value of the accumulator is 0, store a value of 100 in the accumulator. Otherwise, store a value of 0. Okay. So here's what I do. Add P0. So this will bring the value into the accumulator. That might not be what I want. Let's just move it. Let's just move it. Move it. Move P0. Accumulator. Not. Move accumulator P1. Sleep 1. Nope. I already screwed it up. Huh. It's doing exactly the opposite of what I want. Weird. Start with a sleep. I'm sleeping too much. Go away. These chips are synced up to each other, maybe? Nope. I do have to do something. What am I doing wrong? I'm just stabbing at things because I'm tired. So let's see. Sleep 1. Don't do anything first time. Sleep 1. It's now 100. So I want you to move the opposite of 100 in there. Move P0 in between later. Let me get past that already. Oh, it is going to do it. So I was wondering, the code seems like it will do this alternate thing. Oh, I just put a big fingerprint on my phalanxes. Actually, it lined itself back up with it. Oh no. So, okay, alternate timing is wrong. No. I've never tried messing with the X buses yet. I can move an integer into them, I believe. What if I just cheat? What if I do this? Do these two things at once. Move. Using this other port. 0, 1. Yeah, that's fine. Same. 100 F1. It's fine. Go this way. That bridge. This way. Yay, wires cost nothing. Type this way. Okay, so it won't work. Because it's a different type from the output. I see. Okay. Shoot. About... It's cool, man. Don't do those lines of code. A quick comment. See that? Keyboard shortcuts. Okay. Get my 0, 1. Do I have a second? Ooh, I have a P0 and a P1. Oh, I have a P0 and P1! What am I doing? Am I crazy? Must be late. Okay. Let's do this. Do this. I know. It's okay. P0 gets click 0. Okay, there we go. Move 0, P1. 0, move 100, P1. Okay. Get all this wire. Man, I'm stupid. Big secret, guys. I'm stupid. Go. What a piece of cake that was. Or just that part. The rest of it's wrong stuff. Okay. Okay, so these look like there's a pattern to this that I can exploit, right? So for drink 0, start high for 1, 2, 3, 4, 5, 6. 6s again. 6, 4, 6, 4. Okay, so let's start with this. 100. Oops. 100 p.m. Sleep. 6. Sleep 0. Sleep 4. Really look nice. Oh, why are there three coppers in there? 3 wires in there for some reason. Whoop-oo. Whoop-oo. That's fun. The animation that shows up while you do it is fun. I like that. Okay. Let's take a chip. Can I do this in one chip? Can we just program the whole thing in one chip? I probably could. Oh, I can't because I don't have the outputs. Let's do this. Wires are free. Rub this all over here. Sweet. The whole thing. Okay. Create a chip that has a low edge detection. Start doing this. Looking for a 0 on this line. Say, hey, I found a 0. Draw this pattern. Okay, let's try that. Probably should be using these things, but oh yeah. Write more code. Complicated code. Alright, test the quality. P0. And if it's a 0. Okay. Test the quality. Later. Okay. Recreate that thing that I don't remember already. Let's see. Nope, other way around. So, test the quality. See if the accumulator is 0. Alright, so I want to check the following. So check if the accumulator is 100. If it is, check if the U input is 0. So that's checking the falling edge. Cool. Okay. That means the accumulator is 0. In this way. Or it is a falling edge. So if it's falling edge, do the following. P1, move P1, 100 P1, sleep 1, P0, P1, sleep 2, move 1. I'm out of space, sleep 1. Yep, so that won't work because it's too large, because I'm trying to do too much into one chip. How about this? Do this. So this is using something that is also in this other, using multiple chips to store state, or to handle my state input. So instead of having to do that here, I could do this through this somehow. Maybe? Maybe? Okay. So I'm going to say, move a false statement to x1. Similarly, move true to x1. Okay, so that's going to be my x0 port, so SLX. SLX is a, no, what is SLX? I have no idea. The language reference. Sleep until data is available to be read. Okay, interesting. Oh, this is called X0. Okay. Probably just a good idea. It probably doesn't matter because I think there will always be data on this X1, but that's an interesting design choice. I also want this the other way, don't I? Or maybe the other way. No. Oh, interesting. Or by a fluke, I do want that to be this way. Because it's activated. I want this chip to be activated. This is for drink 1. I love how these wires line up. Okay, when it is activated, do this. Okay, I'm just doing that. Move 100 to P1, sleep 1, 0, P1, sleep 2, move 1, P1. Sleep 1. Hit it? Move 0. 0. Is it gonna work? I don't think it's gonna work. Hey, what are you doing? Oh, you're writing, but that's not reading? I don't think I understand that bus. How does X bus work? Synchronized protocol. The read or write is accompanied without a corresponding and a connected block. The operation will block. So that is what's happening. It is blocking on that. Shoot. So what can I do to this? Do I just move that into nothing? Is there garbage? There's no garbage. Is there? Even with that, probably just junk it. Throw it in something. Don't worry about it. I can check the quality on it. That counts. Anything counts. Okay. Two. Screw it and test that. Test if it's equal to 0. Okay, test if x0 is equal to 0. Man. If it's equal to 0, don't do any of these things. Look at that, it got interesting. Look at that, it worked. Alright, I feel okay about this a little. I mean, it feels cheaty. It feels like, or I should say, it feels like there are smarter ways to do these things. And I am not using them. It's using all the power right now. This guy's power hungry. Mad with power. I guess it's because it's flipping. Okay. These feel alright. So next step, similar. Detect an edge when it's low. Oh, I'm gonna have to bridge this, aren't I? Okay. Similar deal. We're going to... Oh, but I can't pump things out on that one anymore, can I? Shoot. Because I don't have enough space there. Code space. Oh, but I can invert. Okay, let's do this. I'm going to take over both those things. I mean, if I just had a generic invert, it would be so much easier. It's all over the wall. Not drawable anymore. Okay, let's see. Hmm. Take. Okay. Do this. What am I doing? What am I doing? I don't need. Yeah. I don't need a special pin. I can just do that. Ah! I'm not going to use anything. Use anything I want. This way it seems that a little better. You know, don't worry about it. Okay. Let's check falling edge first. Is it only? No, it's not every falling edge. Oh, let's go there. Track one falling edge. Sweep away the rest. Maybe? Oh, this won't do anything. I just need you to invert the signal. Wow, there is a signal. There's a 1. Shoot. Okay, this won't work, but let's do it. Invert signal. Move. Let's just do it. Let's just give me on keys. Close, but very wrong. Yeah, this won't work unless. Let's see. What if I try to rewrite this into this? What does this give me? Use that same invert. What if I just do it? Okay, yeah, this, I mean, hypothetically, this saves me money. I can get it to work. Copy paste? Copy paste? Yes, okay, good. Goodbye. Let's see, one. Which I will change. That's okay. Make sure that's okay. And then I just put my invert there. Cool. All your P0s will become P1s. Strike that, reverse it. Yeah. Okay, because I'm moving you to here. Nice. This is asymmetrical. I like that. You, meanwhile, you are my new friend. P1 on. This is already activated. So, move 100 to P0 means move 0 to P1. Zero with the numbers. Move. One. 3, 0. Okay. Neat. Neat. What happens if I get rid of this line? This line. Okay. Yeah, okay. I don't want that. Cool. We have ourselves a working ship. Go. So I've learned nothing. I was really hoping that I'd learned a generic inverter here, but I didn't do that. That's not what I did. Somebody did this with 6? They did this on like 2 chips? That's crazy. I don't think I'm smart enough to figure that out. I'm glad so usually the first time I do these kind of things, I'm just glad that I'm not like the worst person to ever accomplish it. That just makes me happier. Cool. That song that's about a rogue loop incident. That sounds terrible. You may be entitled to compensation. Rogue loop thing, but a self-driving car appears to disregard humans and continues to drive around. You feeling yourself unnecessary and going orders to stop. Oh, that's terrifying. That's the song. Bring out the Baron. I like this Joe guy already. Baron von Schnaps. This man is drinking in the play, the telephone and off the rails. Your personal score keeps the giveaway at their events. Consequently, what would be a foul? Surely not individual drinks. I don't remember the actual rules. I think I'm going to call it a night here. With the new rubbish audio thing and the Baron. Maybe one more game of Solitaire. Oh, this is the PDF. Yeah, what I have printed out already. The mail is the main menu. Control panel is settings. Let's do. Yeah, play a little Solitaire again. It's weird that it's a nice break from hard thinking. Maybe it's just a break from planning. It's still thinking. It's just not planning. Don't have to worry of as much. It's like while playing this, everything is going to be okay. It's not. It feels like it. The stakes are lower. I don't know what this rose gets me. That was probably a mistake. This is better. This is better. Bye. Go. Oh, something's blocked. Okay. Yeah, it feels good. Let's do one more. The same kinds here, which is a problem. I can do a lot of it with this. Actually, probably a bad idea. Yeah. Probably a bad idea. See you later. Oh, I can't bring it back? Oh, okay. That's kind of neat, but okay. That'd be useful to have. Nice. This one's there. 6, 5, 4, 3, 6, and 7. That'll do it. Yeah, it's common, but a good place to end.